Hello friends, our today's point is inverses. Friends, first I will tell you what is meaning of inverse. Okay, suppose A is a matrix. Okay, coefficient matrix Ax equal to B. Simple linear equations represented into the matrix form. Okay, Ax equal to B. Here A is coefficient matrix, X is unknown matrix, and B is our right hand side of the equation. Okay, now inverse of A is denoted by A inverse. Okay, if you multiply this A inverse to A, it will give us identity matrix. Okay, if you reverse the order of multiplication, suppose I will write down A previous and then A inverse. Okay, then also it will give us identity matrix. Okay, now if you relate this situation with the number, suppose I have one number considered 2. Okay, I will if I will multiply it with 2 inverse. Okay, it will give us 1. Okay, it's same situation. Okay, here we will get 1, here we will get identity matrix. Okay, I inverse is like this. The important thing is how to find out the inverse of the matrix and what is its application. Okay, what is its use. Suppose somehow I get the inverse of the matrix A inverse, then our aim is always to find out, just a second, our aim is always to find out X. Okay, now how can you find out X? If you multiply both the side with the A inverse, see, A inverse A X equal to A inverse B, then you will get here identity matrix. Okay, means I X equal to A inverse B. Okay, finally X equal to A inverse B. We know the property of the identity matrix is it results back to our original matrix. Okay, X, no change on the matrix if you multiply to the identity matrix. This is a, just a second, this is a very important application. Okay, of the inverse. See here, A inverse B gives us X. I think it is clear for you the application of the inverse, and we will see how to find out. But before that, we will note down very few important point about inverses. Okay, just a second, I will open it. Friends, please don't get confused. I will explain each one by one. Okay, these are few notes about the inverses. Okay, these are very simple. Just see one. This line 1 inverse of matrix A is A inverse such that A inverse A equal to A into A inverse is identity matrix. It is a like definition of the inverses. Okay. Now note down the point 2. Inverse exists if and only if matrix produces n pivots. Okay. N is our number of rows. Okay. If matrix have n pivots, then only inverse is possible. Okay, third point is if A is invertible, then only one and one solution to Ax equal to B is present. Okay, like this we have seen. Okay, this is possible only if we have only one inverse. Okay, suppose there is non-zero vector x such that x equal to 0, then A inverse does not exist. Okay, if x is non-zero vector, okay, and if Ax equal to 0, then the inverse is not possible. Okay, if x equal to 0, then it is possible to have inverse of the A, but if x is not equal to 0, then and our equation is like Ax equal to 0, then A inverse does not exist. Fifth point is invertible if and only if its determinant is not equal to 0. Okay, This is a very important point. Please note that if determinant of A is going to be 0, then inverse does not exist. Now we will move to the page 2. Okay, just a second. Now our sixth point is inverse of the diagonal matrices. Friends, if you don't know what is meant by diagonal matrix is a matrix whose all elements are 0 except its diagonal elements. Okay, none of the its diagonal elements is 0 and all other are 0. Okay, uh, inverse of the diagonal matrix is very simple. Just see here, just take inverse of all the individual entries along the diagonal. See, here is d1, here is 1 by d1, d2 1 by d2, like this. That much simple is this. Seventh point is inverse comes in reverse order. I have written over here on a proof. Okay, a b c whole inverse equal to c inverse b inverse a inverse. If you see, order is reversed when we are going to apply inverses to the individual. Okay, proof is written here. ABC inverse into ABC. I have used here, see here. If you look at here, A inverse into A will be I. That's why C inverse B inverse BC. Then B inverse into B is going to be I. That's why third is C inverse C. And finally C inverse C equal to I. That's why this is true. Okay, from this proof. Now we'll move to the Gauss-Jordan example. Okay, but before that we'll see principle. Okay, look at here, calculation of A inverse. Okay, I'm going, the Gauss-Jordan method can be used to find out the inverse of the matrix A, but there is one principle behind this method that is going to I'm going to explain you. See here, what we will do, I will write down first given matrix A, and I will make one partition, and at the right hand side I will write down identity matrix of the same shape. Okay, suppose A is, I have written one matrix C, 1 2 3 4 5 6 7 8 9. Okay, this is one matrix. Okay, this is a 3 by 3 matrix, right? What I will do, at the right hand side I will write 0 0 1 0 1 0 0 1. Okay, the left hand side is a matrix of which our aim is to find out the inverse. Okay, this is A, this is I. Okay, first write down like this, A I, and after that, you know, A can be written as L U. Okay, I have shown you in our previous video. Okay, how to decompose A in the form of LU. After that, what we'll do, we'll multiply L inverse to the both the side. Just a second. I will multiply L inverse to both the sides. Then what will be resultant? L inverse into L will be I. I into U is U. And at the right hand side, L inverse, like this. Our next step is, I will multiply U inverse to the both the sides. See, U into U inverse will be I. See here, and at the right hand side, U inverse L inverse. Okay, Then third step, friends, we already seen how we can write down u inverse L inverse to Lu inverse. Okay, means if A B inverse can be written as B inverse A inverse. Okay, like this. Lu inverse can be written as U inverse L inverse. Okay, and finally we know Lu is A, that's why A, and finally A inverse. Okay, like this. I think you understood. Or our aim is just reduce this A to the I and I to the A inverse. Okay, the steps to do that I have written here. Okay, we will see with the example. Okay, just we have given A, we will reduce this A to I and this I to A inverse. Okay, this I will get A converted to A inverse automatically when you are going to reduce this I matrix A to the identity matrix. Okay, you will see. Just we will start with the example. God Jordan example part 1. Just see. Friends, I have written one examples. Okay, I will explain everything. Please don't get confused. God Jordan method to find out A inverse. Simple, very simple example is this. Just what is here? I have written one example A. It is 3 by 3 matrix. Okay. I have partitioned it. Okay. I have written a this. This is like A I. Okay. I is of the same shape as that of A. Then our next aim is to convert this AI to UL inverse. Just before say here, means first we will convert this A to upper triangular matrix. This is our first aim. Okay, how can we do? Just see here. If you subtract 2 times row 2, row 1 from row 2, you will get 0 here. Okay, means I want to make 0 here, I want to make 0 here, I want to make 0 here. To for that I have carried out few steps, okay, which gives us this matrix, and or finally we want 0 here also. Okay, if you subtract row 2 minus 1 times row 2 from row 3, you will get an upper triangular matrix. Okay, that was simple is this. I think you know how to convert A into U. If you don't know, you can see my previous video. Okay, during carrying out converting this A to U, our carry out same operations on the right hand side, means on this identity matrix. Okay, then finally you will get I here, L inverse here. Okay, this side is L inverse, this side is U inverse. Now our next step is to convert this U to I. Okay, how can we do? Now we can first we have to make zeros above the diagonal, same way as we made 0 below the diagonal. Okay, now our aim is to make 0 above the diagonal, means I want 0 here, 0 here, 0 here. For that, what we'll do, just a second, I'll open second part. See, our matrix was in part 1 was this. Okay, this side. If you subtract, if you add 2 times row 3, okay, 2 times row 3 to the row 1, okay, then you will get 0 at this point. Okay, see here, like this. Now, or and if you subtract minus 1 times, or if you subtract row 3 from row 1, you will get 0 here, like this make steps, and you will get 0 above the diagonal. See here, if you see here, you will get this. Now just I have to make partition to understand. Now we reached at second last step. Okay, uh, it is a diagonal matrix. Okay, all of the elements are 0 excepting its diagonal, but our aim is not completed here. We have to convert this diagonal to 1. I want to make this matrix as an identity matrix. Okay, just see here. What for that, what I will do, I will divide row 1 by 2, then row 2 by minus 8, then row 3 is we don't need to divide row 3 because we already have 1. Okay, then we will get this left hand side as an identity matrix, and finally right hand side as A inverse. Okay, just a second. This, like this, we have to find out A inverse. Okay, this is a Gauss-Jordan method. One more important thing I want to tell you, that determinant of matrix A is the product of their pivots or pivots. See here, we have 2 minus 8 and 1 as a pivot. If you take product of this diagonal, 2 into minus 8 is minus 16, into 1 is minus 16. Okay, this is our determinant A. You can cross check by finding out determinant of A. It will be minus 16. Now we will move to the second part, breakdown. Okay, here we will see when Gauss-Jordan method is get breakdown. Important thing is, when matrix is singular, then we cannot find out A inverse. Okay, by any method. See here, I have written one example. Okay, this is 4 by 4 matrix. It is like upper triangular matrix. Only if you say, look at diagonal of this matrix, we have 0 at the third column. Okay, see here, we have 0 at the diagonal. Now what we will do in Gauss-Jordan method, at the last step we divide by the diagonals. Okay, to make identity matrix. Okay, suppose we have d1, d2, d3, like this. Okay, at the final second last step, but our aim is to make identity matrix. Okay, for that what we will do, we will divide row 1 by d1, then row 2 by d2, then row 3 by d3. Okay, then we will get identity matrix. But in this matrix, if you going to divide by 0, then it is not possible. Okay, division by 0 is not possible. Means if matrix contains 0 pivot, which is 0, pivot which is 0, then Gauss-Jordan method is get breakdown, because that matrix is singular matrix, and inverses of singular matrix is not possible. Okay friends, that's it for this point, inverses. We will see transposes in our next video. Thank you.